Okay, so this is the workpiece for this module. We are going to ignore the half 13 hole in the back for now. I think I'm going to end up thread milling that in another module just to show thread milling. So the main purpose of this one is to do OD threading on the lathe, and then we'll do a plunge cut here. So this will show the plunge parameters. So we'll fixture this up, 0, on the end. We'll rough it, finish it, taking care of this cutout, groove it, and then thread it. Okay, so we'll go back into, we'll get the model into Mastercam, and I'll just meet you back there. Alright, so this is the model loaded into Mastercam. One thing we need to do is take care of moving it. So we'll go to Dynamic, go to the end, bring it over the X to the existing top plane, and hit green check. So there we are there. One way to make sure that you are on that plane is to go to Analyze Entity Properties, select this arc, and make sure that it's 0, 0, 0. Green check. So top view. Alright, let's go to Machine, Lathe, Haas ST. We'll go into our stock setup. The stock, in our case, is going to be a 2-inch OD. Length will be, let's say, 5 inches, and let's just preview. That'll work for us. We'll grab the jaws over here, hit enter. And then as far as the chuck jaws, we will go to parameters and from stock and grip length of 2 inches, and let's just see where that leads off. Not quite, because we are going to part this off, so we'll go to 1.5 inches, 1.75. That's still not enough clearance for us, so preview lathe boundaries, 1.5 inches. That should work. Okay, so we are all set with our stock and jaws set up. So for toolpath group 1, this will be op 1. Alright. So let's take care of some of these, deburring at least some of these radii. So we only got really one to take care of, and that's this one here. So let's go ahead and go to solids, constant 1 fillet, select that edge, and make it 0.015 thousandths, so green check. Okay. So there's a workpiece. Alright. While we're at it, we'll just take care of a facing pass right now. So turning face, or a facing pass, sorry. Select library tool, tool 101, the standard CNMG insert. Tool 1 is good, feed rate 10, 500. For surface footage, max of 2000, just to be safe. Coolant should be on. Face parameters, everything here should be okay. Green check. And there's our facing op. So good time to save. I'm going to save this lathe part 1 right on my desktop. I'll transition here, let you catch up, and we'll come back in and take care of the turning operation. Alright, so let's take care of roughing and finishing this outside diameter. So first thing we need to do is take care of the threads. Half 13, the major diameter per class 2 is a max of 498, so we'll shoot it to 497. So we need to modify our geometry. So we can go into here, go to model prep, push pull, select the diameter, remove history, and then select this arrow. You can see it changes. We can go 0.497 divided by 2 because it's on radius, and hit green check. And if we go to top view now and zoom in, you'll see that we are undersized, and that's what we want. So that takes care of the threads. The key here is make sure we don't select the 2D geometry for turning. We won't. We'll be using 3D geometry. So we're gonna take care of all of this, okay? And I'll show you the plunge conditions, but we're going to use a CNMG as much as possible, and then we'll come back in with a center cutting tool and take care of this radius. So let's get into our turning operations, rough. And notice we are underneath, so select here and here, and then make sure that we are underneath, so we are selecting the right diameter. So that's good. Green check. We'll select our 80-degree insert. Speeds and feeds will increase 500 for SFM. Max will be 2,000, and 10,000 fine. Rough parameters, we'll go 050 for depth of cut. Stock to leave is fine. Lead in, lead out. Make sure we lead out, extend it by 100 thousandths. Stock recognition, use stock for outer boundary. Plunge parameters, we'll leave alone for now. Hit green check. There's our toolpath. Looks familiar. Okay. Now, I want to show you plunge parameters and see what it's going to do. Plunging parameters will allow you to plunge into that arc. It's not going to work out for this. Our insert does not have enough back clearance. But right now we have no plunging. Plunging on face and OD. OD only, face only. Okay. So if we move it to OD, you're going to see that we are going to have crashes because it's going to try. See where it plunged in? It's going to try to plunge in right there. We don't want that in this op. That's just what plunge. That's why I picked apart with that feature, just to show you that. So we'll turn that off for this one. Green check, green check. So there's our roughing. Minimize this, minimize this. Let's go to finishing, and we'll select here and here. Make sure we are at the underside of the workpiece. That's good. Green check. And we will use the same tool for this. I don't think there's a need to go to a different tool on this operation. So we use the same one. 600 for SFM, 2000 limit, 3000 per rev. That'll just save us a tool slot in the machine or save you from changing a tool. This is aluminum and or steel. We're gonna make it one part. We can rough and finish with the same cutter. So that's good. Lead in, lead out. We got to lead out by 0.090. That'll be good. Not 100 because we got to stay back because the 10th that we left. Plunge parameters we're going to leave alone. Green check. And there it is, roughed out and finished. So that's good. Op 1. And what I'll do is I'll transition here. And what we can do is take care of this with a center cutting tool. We'll load one up and cut this little radius. Okay, so one thing I noticed is that we're going to be using an 1/8 inch parting tool, and I did not go past the end of the part enough. So I went back into my roughing parameters and extended lead in and lead out to 150 thousandths, 140 for the finish. So make sure you do that. Go ahead, op 2. Let's do a new toolpath group here. This will be radius, and let's go ahead and cut this radius. So first thing we need to do is go to rough, and we're going to select this geometry and hit green check. So you'll see I already have a VNMG center holder in here, but in select tool library, I found that in the Kennemental library right here. Hit green check. I have that tool up as tool 2. I'll update the speeds and feeds to 500 SFM, assuming we're in aluminum. Again, that's probably okay for mild steel, but we're assuming aluminum for now. It's probably what you're going to make this out of, but steel sometimes, depending on where you are, how class is going, I could assign this part in any material. So feed rate will go to 5 thousandths. All right, take it easy on this one. Rough parameters, depth of cut, 50 is okay. Let's go to 30. Stock to leave in X and Z. Let's leave 5 thousandths. And we're going to use remaining stock, adjust stock, make sure that the orange boundary is good. Green check, that sort of tells us where the stock is. We'll go to lead in, lead out, and I want to extend both of these by 50 thousandths. To ensure we get a clean cut. The other thing I'm going to do is to automatically calculate entry vector. Select both of those. That'll help in our situation. Green check. And then that doesn't always work, but in situations where you're plunging into the workpiece, like even if this is a button cutter, I would still try to use auto calculate. If for the reason you're getting crashes when you're modifying the entry vector, try automatic calculate. If that doesn't work, try IntelliSet. If that doesn't work, then you really got to mess around. For whatever reason, something's not right. There's a lot of variables here. But on situations, will try to use auto calculate vector a lot. I usually show this first just to ensure that you know how to use it. But try auto calculate vector and see if it gives you what you want. Green check. Everything here should be okay. Hit green check. Now, no error areas. Let's hit green check. And let's check the geometry. Notice it's on the wrong side. Right click. Change side, so the arrows are pointing up. Green check, regenerate, nothing. Why? Go to parameters, plunge parameters, allow OD plunging, green check. Now we're good. Okay, so there's those plunge parameters. Let's go hit play. We can watch this run. There's the roughing. Now, don't worry about the blue lines cutting in, because if we go forward, you'll see the insert is not actually, if we just go back, the insert is not actually cutting where the blue line is. That's a tool nose radius compensation working automatically because we use computer comp and Mastercam. So you can watch the end of the cutter or cut. It's not exactly where the blue line is. That's the programmed path. Okay? So there's that roughed out. let's go ahead and finish that geometry. Okay, so I'll turn the visualization off on that. We'll go into finish, select the geometry, green check. Same tool is fine, increase this to 600. 3,000 per rev is fine. We'll go into our lead in, lead out. Make sure we extend it by 50 thousandths on each side. Automatically calculate. Okay. Let's see what happens with there. Green check, plunge parameters, allow it on the OD, green check, and then hit green check again. Cannot compute entry vector. Yes. Why? Let's see what happens. Ignore warning. Let's just see what happens here. See how it's all over the place? See where it doesn't, it's all out of whack? Why is that? Let's go into geometry and change side. So the material's on that side, or the cutting tool, the geometry's comped that way. Then go to green check and see we have no issues. Notice how the tool nose radius compensation changes throughout the part. If we watch this run, I'll slow this down to backplot. You'll see that the cutter looks okay. Just turn this down a little bit, hit play. And watch it run. See, the cutter should line up. And the gray you're seeing is left over. Okay? So if we want, we'll go into, not file, home, analyze toolpath, make the tool darker, and if we put the tool here, look where the tool is. See how it's compensating to the area we want to cut, or the geometry we want to cut? Same over here. See how that works? And up and out of the way. So that's good for that one. There's the radius cut. Alright, we'll do a new toolpath group. This will be groove. And, I mean, there's no real reason to separate this and this op, because if you select them all, they'll all post anyway. But this will help us just stay organized in a learning environment. So there's our radius work. Actually, before we do this, let's go into verify and watch this run. So we'll hit play, face, turn, finish, groove, groove, finish. All right. If I hit back and slow it down again, face, let it cut. This is the OD turning. OD finishing. Make sure we are cutting a little undersized the wireframe, and we are. It's perfect. And hit play and watch this rough. And hit play, let it finish. Looks good. So we're all set up to that point. Let's take care of this groove, and then we'll get into threading. Alright, so let's take care of this thread relief. So in the grooving toolpath, we'll go to groove. We'll do chain. Hit green check. We'll select from here and red cursor over to there. That's as far as we're going to go. Green check. For a tool, we can go into, get out of the Kennemental library and get into just the regular lathe inch library. And we'll select an 1/8 inch radius 10th grooving tool that's offset right hand. So hit green check. This will be tool, should be 3 in our case. Okay. Speeds and feeds are okay. We'll increase the SFM and limit it to 2,000 in our G50 line. We are RPM for finished middle, so we can do constant surface speed for that. It shouldn't change. We do have a radius, so it is going to change a little bit, but we'll live with that. That's good. Groove shape parameters, everything here is fine. Roughing parameters are okay. Leaving 5,000 is good. Groove finish parameters. The one thing here we have to watch out for is our lead in. I like to lead in at 6 o'clock in this case. Green check. Green check. We're probably going to get a collision detection a little bit, but we'll verify through it to make sure we don't, see how it's going to touch a little bit, but a lot of that's going to do with your tool compensation. So hit play. Or actually, I'm going to hit stop and hit S and get ourselves there, and then we can slow it down and hit play and watch this run. Here's our rough grooving working in the middle, getting rid of most of the material, leaving 5,000, and then it's going to work around. Come in, roughing out the material. And then we'll slow down for the finish pass. And this should be the finish pass. Coming in, contouring around. Good. Coming up, coming into this side, just barely touching this surface. Coming in. and finishing up the groove. So there is our groove toolpath. Okay. I just want to double check. Tool 2, so this would be tool 3. That's correct. Good time to save. So there's our thread relief, and now let's get ready to thread this component. All right, let's do a new toolpath group, and this will be thread. All right, and I'm just organizing it this way. We could have done leader lines off of here, but in reality, I probably wouldn't have separated these. I probably would have set them all in a row, but I thought this would help separate the program and keep people organized and help if you're having issues, especially communicating via email. So go to thread, and we'll go to lathe thread. We'll go to select library tool, and we'll be in the lathe inch database, and we'll select this OD thread right, green check. That should be okay. You just gotta double check, depending on what pitch you're cutting, what the specs are on the insert. So we should be okay. So just double check that. We're good to go on this one. So hit green, check. There's also other ones in here that you can update. Different inserts. Okay. We use a standard unified thread 60-degree insert. Okay. We'll hit green, check. So then the feed rate will be determined later. We'll go inches per rev for feed rate. That's fixed. Spindle speed will be, let's go a constant RPM of 200 max. We'll go 500, right? Because there is a limit on how fast you can go. You have to look in the Haas manual when threading at different pitches. So we're going to go thread form, select from table. We're going to go to 1/2 inch 13. Check. And then we'll go select from table for our allowances, and we're on class 1A and 2A, and we'll select a 1/2 13. And there's our 498.5, the max that we talked about earlier. We're at 497 for the major, so that's good. So we'll leave that there. The minor we'll leave alone. It's a little bit on the higher side. This is where it's adjusted to. We're going to live with this. We could comp it a little bit, but I like to use the allowance table. That I do like to use, because again, the major's not 1/2 inch. It's adjusted. The majors are all in the machinist handbook or in the tables in Mastercam. So that's what I'm going to go with. That's what I usually do. And sometimes I do comp it at the machine just to make sure I don't go undersized on the pitch diameter. That's up to you. But as far as programming, I program to nominal when possible. We could comp it again if you turn them off. That's what you're going to get. That would sort of do the same thing as comping it at the machine. It's up to you. So just know that, you know, this is how you take into account the actual specs versus nominal, or nominal per like 1/2 inch instead of 498.5. So the end position, we're going to go minus 0.8. That should leave us somewhere in the relief somewhere. Thread cut parameters, the NC code format, I prefer to do longhand on the CNC. I like to do equal area on the insert. The amount of first cut is 15 thousandths. The amount of last cut is going to be 2 thousandths. And I want to do 3 spring passes. So we're good there. We'll hit green check. And there's our thread. So if we go to backplot and work through this, we'll see the threading tool cut, and it's going to keep an equal load on the cutter. That's why the geometry is deeper to shallower as you go, which is what you want to be optimal. It's going to take spring passes here. Alright, so the other thing I like to do sometimes is go into Analyze Toolpath, and you can see the thread form. Okay, we're in good shape. Alright, XO2034, which is 406. If you look at the machinist handbook on class 13, 4069 is the minor, so that would be good if we comp it. Let's say 5 thousandths on the first part, and then comp in to measure pitch diameter. That should be fine, but the X is 2034, which is roughly 4068, and the machine handbook is 4069 for the minor, so that is accurate. So we'll live with that for now. Again, I would comp it at the machine just in case it cuts, your tool touch-offs aren't accurate. That way you're not going to go too deep and, you know, get rid of the pitch diameter tolerance. But we'll hit green check there. So this part is pretty much programmed except for the parting off. So let's do that right after this transition here. I'll try to break this up a little bit for you. Okay, so let's go to turning, and we'll go to cutoff. And I gotta select the cutoff boundary. So you could try to select it, like there should be an endpoint right here somewhere that you can get. If you can't, you'll see like an X appear where the intersection is. If that doesn't work, like in other examples, I hit the space bar and I'll look at the drawing. And OD is 1.5 and the part's 3 inches long, so it's going to be minus 3.0, comma 0.75, comma 0. And there's our endpoint for the tool. Although that tool might work, we're going to use the 1/8 inch cutoff tool right there. Green check, usually a little longer. Again, in the shop, depending on what you could use, a grooving tool in theory to do both. It depends on what's available. We'll rename this to a 5. And then max spindle speed will go to 1,000. And spindle speed will go, let's say 300. And that's fine there. Cutoff parameters from stock. We'll put a radius in of 15 thousandths. And that should be okay. Let's hit green check. And there's our part off. Now, again, the hole will take care of probably another module. That'll be a thread milling op at some point. But we are probably not going to part this straight off. I would leave a spud. I would do that at the machine. Just, the last line, instead of going to X minus whatever or X0, to go to X2, 0.2, and then just break it off by hand. I find that to be the quick way to do that if you want to break it off by hand. If you want it to drop and wrist drop on the part, that's fine. If you damage it, it's on you. So we took care of the deburring on this side. If we watch this toolpath run, you'll see the cutter go around like that, and that's what we want. So now we're ready to go to verify. So we'll select everything. And good time to save too while we're at it. Go to verify. And then we'll hit play. And there's the face. Face to 0. Rough it out. Finish the workpiece. Rough the radius. Finish the radius. Do the thread relief. Thread the part. And part the part off, and the part disappears. If you want to ever change that, go to cutoff, go to parameters, and go to stock update, and keep both pieces for our example. Green check. Select everything and verify, and we can quickly go through this now just to see the difference. There's thread relief, and we can slow down and watch this thread if you want. So it does a decent job of showing you that. My graphics aren't up all the way, but there's our threading. Spring passes. There we go. And then we can hit play. Parts it off with the radius and keeps both pieces. So there's our workpiece completed. That's it for this one. Again, do not worry about the hole. This is the lathe turning unit, so we'll just take care of that. There'll be another video on the backside. We'll hold this in a V-block or soft jaws or something, and we will drill and thread mill that just for an example on the milling machine. So if you have any questions, let me know, and thanks for watching.